Okay, hello. Good day, everyone. Today we're going to discuss course outcome 3 of college trigonometry with solid mensuration. Course outcome 3 deals with the fundamental principles of solid mensuration. This means that we are going to solve for some of the measurements that involves area, volume for solids. But before we can do finding the area and volume of solids, we must take into consideration some of the phases of these solids. That is why we need to measure perimeter and area of some plane figures. So for today, um, at the end of this lesson, the students should be able to, number one, apply the appropriate formula to calculate perimeter and area of various plane figures, including triangles, squares, rectangles, parallelograms, trapezoids, and circles. Number two, solve real-world problems involving perimeter and area. Mensuration in mathematics is the theory of measurements. It is part of geometry that is concerned with three dimensions of measurements. If we are referring to one-dimensional measurement, we are referring to lengths. For two-dimensional measurement, we have area. While for three-dimensional measurement, we will be having volumes. A polygon is a closed figure determined by three or more line segments that lie on a plane. The line segments that form the polygon are called its sides. Here are some of the examples for polygons. The first one is a square. The second one, a triangle. The third one is 6 hexagon. Next is a pentagon, and the last one is a general quadrilateral. A regular polygon is one in which each of the side has the same length and each angle has the same measure. An example of a regular polygon would be a square. It has equal sides, equal lengths of sides, and equal angles. All angles measure 90 degrees. This one is a hexagon, and all the lengths of the sides measure the same, and all interior angles are the same as well. So that's why it is a regular hexagon. Our pentagon here is also a regular pentagon because the lengths of its sides are the same. The name for a regular polygon is based on its number of sides. The table below lists the names of the polygon that have 3 to 10 sides. So for a three-sided polygon, we have a triangle. For a four-sided polygon, we have quadrilateral. Sometimes we call this a tetragon. For five-sided polygon, we have pentagon. Six-sided polygon, hexagon. 7, heptagon. 8, octagon. 9, nonagon. And 10, decagon. You may wish to check how to name other polygons with more than 10 sides. Triangles are distinguished by the number of equal sides and also the best measure of its angles. By sides, we have scalene, no equal sides. Equilateral triangle, all sides equal or all sides congruent. 1, 2, and 3 are congruent. And for isosceles triangle, we have two pairs of sides equal in length. So for this isosceles triangle, we have AC is congruent to BC, and the angle A is the same as angle B. For an equilateral triangle, all sides are the same. That is, AB is equal to BC equal to AC, and all the angles A, B, and C measure 60 degrees. A scalene triangle has no two sides of equal length and thus no equal angles. For the angles, basically for a triangle, the two sides would be acute angle. The naming of the triangle based on angle is dependent on the third side. If the third side is also an acute angle, so we have an acute triangle. So all angles would be acute. If the third angle is an obtuse angle, so we have an obtuse triangle. So this one is an obtuse angle. And if one of the angles is a right triangle, a right angle, so it would be a right triangle. For quadrilaterals are four-sided polygons. Quadrilaterals are also distinguished by their sides and by their angles. So basically, we have our general quadrilateral. So a general quadrilateral is a four-sided polygon. If two pairs of opposite sides are parallel, we will be having a parallelogram. So we have two pairs of parallel sides. If we have only one pair of parallel side, we will be having a trapezoid. So two sides parallel or a pair of parallel sides. Under parallelogram, if all of the sides are of the same length, we will be having a rhombus. If all of the sides of the parallelogram measure the same, it would be a rhombus. If all of the angles of the parallelogram are congruent, or are all measuring 90 degrees, it is a rectangle. While a square is a rectangle having all sides congruent or all sides measure the same. So basically, a square is a rhombus and a rectangle at the same time. An isosceles trapezoid have two sides which are parallel, and we have non-parallel sides equal in length. For a circle is a plane figure in which all points are of the same distance from the point O, which is called the center. The diameter of a circle is a line segment with endpoints on the circle and passing through the center. In the figure AB is the diameter of the circle. So AB joins 2 points on the circle and it passes through the center of the circle O. The variable d is used to designate the length of the diameter of a circle, while the radius of a circle is the line segment from the center of the circle to a point on the circle. That is why we can have diameter is equal to 2r or radius is equal to d over 2. Perimeter and area plays a vital role in the computation of measurements of a plane figure. Perimeter defines the distance of the boundary of the shape, whereas area explains the region occupied by it. So area is the region occupied by a shape. It is usually measured in square units like meter squared, centimeter squared, and inches squared. Perimeter is the total distance covered by the boundary of a shape. Perimeter is usually measured in meter, centimeter, inch, and feet. Let's go into details regarding some of the basic formula for various shapes. For triangle, the fundamental formula that we will be considering is area equal to 1/2 of base times height, while the perimeter is the sum of all the sides. So we have length MN plus length NP plus length PM. So that is the perimeter of the triangle. For a parallelogram, the area is base times the height. For the perimeter of the parallelogram, it would be DE plus EF plus FG plus GD. So we take the sum of the lengths of the side. But take note that EF is of the same length as PG and DE is the same length as FG. So we can also consider twice of DE plus EF. For rhombus, the area is again base times height, wherein the perimeter is 4 times the length of a base, or 4 times the length of a side. For the rectangle, the area is length times width, while the perimeter is 2L plus 2W. For square, the area is length times length, so it would be L squared, while for the perimeter, it would be L plus L plus L plus L, which is 4L. For the trapezoid, the area is half of the average of the bases, so it would be B plus capital B over 2 times the height, while the perimeter is the sum of all the sides. For curves, the area for the circle is area equal to pi r squared, while for the circumference, we call it circumference, not perimeter for circles. So we have circumference is 2 pi r, which is equal to pi d, or pi times the diameter. Let's have an example. Consider the quadrilateral below. Determine the area using the indicated triangulation. So we can consider two areas. We can consider area 1 and area 2. Area 1 is a triangle with an area 1/2 of base times height. For area 2, the area is also an area of a triangle, so it is also 1/2 of base times height. For area 1, we need to find the base. So the height is 16 inches, while the base is unknown. We can solve this by taking note that this is a right triangle. So we have the base squared plus 16 squared equal to 20 squared. So b squared is equal to 400 minus 16 squared is 256. So the base, which is 400 minus 256, is 144. So b squared is 144. So that means b is 12 inches. While for the second triangle, we have the base is equal, we have the height equal to 5, while the base is 12. So since they have the same base, so base is also 12. But we need to verify that the square root of 12 squared plus 5 squared, so that would be square root of 144 plus 25 is 169. So C is 13. So indeed, it forms the given triangle. So we have area is equal to 1/2 of 12 times 16. That would be area 1. So this would be 6 times 16. So that is 96 square inches. While for it would be 1/2 of 12 times 5. So 12 divided by 2 is 6 times 5. So that's 30. Based from the figure, the total area, A total, is equal to the first area plus the second area. So the total area is equal to 96 plus 30. So our total area is 126 square inches. Let's have additional examples. Find the area of the shaded region. So for letter A, we can consider this as a rectangle. So the total area is equal to the area of a big triangle, a big rectangle minus the area of a small rectangle. So the area of the rectangle is length times the width. So the area of the rectangle is 30 by 14. So 30 by 14 is equal to 420 square units. For the area of the small rectangle, so that would be 24. Sorry. Let's have a correction for that. The formula is correct, but the application of the formula is wrong. Okay, again, for the area of the rectangle, the big rectangle has the measure 20 by 30. So we have 30 by 20. So that is 600 square units. For the area of the small rectangle, we have 14 by 24. So that is 14 by 24 equal to 336. So the total area now is equal to 600 minus 336. So the total area is 264 square units. For letter B, we have a trapezoid. So the area of a trapezoid is equal to 1/2 of base 1 plus base 2 times the height. We are given with the two bases 12 and 24. Now our problem is the height. What would be the height of this triangle or the height of the rectangle? So to find the height of this, so we have the bases are 12 and 24. So the problem is, how are we going to solve for the height? We can remove the 12 from 24. So meaning 24 minus 12 is 12. So meaning this would be 6 and this one would also be 6 and this is 12. Such that we have 6 plus 12 plus 6, also 24. So we now have the triangle 10 and 6. And we have this as the height. So from that, we can have h squared plus 6 squared is equal to 10 squared. And thus, h is equal to the square root of 100 minus 36. So h is the square root of 64. So h is 8. So the area now is equal to 1/2 of 1/2 of the base, which is 24 plus 12 times 8. So 1/2 of 24 plus 12 times 8. So the area would be 24 plus 12 is 36. 36 divided by 2 is 18 times 8. So the answer is 144 square units. Now, another approach in solving this is cutting this part and placing it here. So we would be having 18 by 8, the height of the triangle. Okay. Next, let's solve for the area of this shaded region. So the total area is equal to the area of the large triangle minus the area of the small triangle. The area of the large triangle is 1/2 of 8 times 6. So that's 24. 1/2 of 8 times 6. So this is our right triangles. So the two legs forms as the base and the height respectively. So 8 times 6 over 2. For the area of the small triangle, it would be 1/2 of 4 times 3. So that would be 6. So the total area, let's have it total. So it would be 24 minus 6 equal to 18 square units. Okay, let's have this one. Carpeting is to be purchased for the family room and hallway shown. What is the area to be covered? So for this, we would be having the area of a square plus an area of the rectangle. So this is the total area. Square plus a rectangle, which would be the total of the figures. The area of a square is s squared, which is 5 squared or 25 square yards. So this is 5. This is 2 plus 1 plus 2. So 2 plus 1 plus 2. So that's 5. So 5 times 5, 25. For the area of the rectangle, the area of the rectangle is length times the width. So that would be 1. And the height would be 9 minus 4. So the total length is 9 minus the height for the square is 5. So what's left is, 9 minus 5. So that's 4. So we have 4 square yards. So the total area is 25 plus 4. So the total area is 29 square yards. Let's have another problem. The roof of the house shown needs to be reshingled. Consider that the front and back sections of the roof have equal areas. So the front and back section of the roof have equal areas. So this area 1 is equal to area 2. Find the total area to be reshingled. So we have to analyze it in such a way that the total area is twice the area of the rectangle. So area 1 plus area 2. We know that the length is 60 feet. The problem is the height. We need to have, or we need to know this height. So take note that this is 24, meaning this must be 12. And the height is 5. So this must be the square root of 5 squared plus 12 squared. So that's square root of 25 plus 144. So that is the square root of 169, which is 13. So we can say that the width is 13. So we will now be having 60 by 13. So the area of the rectangle is 780. And thus, the total area is equal to 780 times 2, which is now 1,560 square feet. If the roofing is sold in squares, each covering 100 square foot, how many squares are needed to complete the work? So if roofing is sold in squares, each covering 100 square foot, so it is basically 10 by 10. So if we need a 10 by 10 roofing, so how much do we need? So that means we needed 6 by mathematically, the answer should have been 1,560 divided by 100 square feet, which would be 15.6. However, there would be some sides, yung 13, which is um, more than ano siya, no? So more than um, itong side kasi na to, 13. So ang gagawin natin, what we're going to do is to divide it by 6. So we have 10 by 10. So yung dimension natin na 60, we divide this by 10. So we need 6 divisions here. So 1, 2, 3, 4, 5, 6. So 1, 2, 3, 4, 5, 6. And then, since we need 13, so maybe what we can do is we divide the tiles into 2, so we can have it as um, so the length is 13, we divide it by 10, so we need 1.3. So what we're going to do is to have 1.5. So the good thing about here is yung parang yung 1/2 niya, or pwede natin i-divide siya by 3, no? So we can divide it by 3 kasi 1.3. So how many um how many 1/3 do we need? So we would be needing actually um 1, 2, 3, 4, 5, and 6. And then so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And then yung point 3, we can divide one block into 3 parts. Tigpo point 3. So we have 1, 2, 3, 4. So I think we would be needing 6 plus 6 plus 4, which is 12 plus 4. 12 plus 4 is 16, which is close to what we are going to have here. So if we divide 1,560 by um, by 100, we would be having 15.6, and we need to round it up to the next higher value. So that's also 16. So we need 16 um, squares. To remove old shingles and replace it with new shingles costs 750 per square. What is the cost of re-roofing? So we have 16 squares times 750. So that would be 16 times 750. So that's 12,000 pesos. Next, a beach tent is designed so that one side is open. Find the number of square feet of canvas needed to make the tent. So let's decompose this into different plane figures. So we have 6, 6, 8. We have another one of that shape as well. 6, 6, 8. We have a rectangle, which is 12 by 6. And the other one. So let's have this one as X. So the other one would be 12 by X. So we need to find the number of square feet of canvas needed to make this tent. So let's have this as A1. This is our A2, A3, and A4. So the area of this trapezoid is 1/2 of 6 plus 8 times 6. This would serve as the height. So we have 6 plus 8 is 14 divided by 2 is 7 times 6. So area of the trapezoid is 42 square feet. This also would be having area equal to 42 square feet. For this rectangle, we have area is 6 by 12. So what is 6 by 12? That is 72 square feet. For this one, for the last one, we need to determine the length of this side. And how are we going to determine that length? We based it from the trapezoid. So this is 6, this is 6, and this is 8. So if this is also 6, this must be 2. So x is the hypotenuse. So that is the square root of 2 squared plus 6 squared. So x is the square root of 4 plus 36. So x is the square root of 40, which is 4 square root of 10. So the area would be 4 square root of 10 times 12. So that's 48 square root of 10. So the total area would be 42 plus 42 plus 72 plus 48 square root of 10. Let us confirm that it is 223.8 square feet. Oh. So this is plus 84. So the total area is wait. 307.8 square foot. So that's the total area of canvas that we need to form the tent. So for some of the resources, you may check on Ron Larson's trigonometry, Richard Hoffman's algebra and trigonometry, and Cynthia Young's trigonometry. So thank you for listening. Bye, everyone.